everyone, the main title of our group project is the role of force and motion in bicycle movement. Have you ever thought that every time we ride a bicycle to class or work, we are actually practicing the concept of mechanics in our daily life? Not only that, by choosing to ride a bicycle, we are also helping to save the earth by reducing carbon emissions from motorized vehicles. Now, our group will investigate a case study of a bicycle moving over a distance of 150 meters. Behind the casual ride, there is an interaction of physical force such as forward pedaling force, resistance, acceleration, and even the moment of force when I turn this bicycle handlebar. Let us see how this mechanical data analysis can prove energy efficiency and bring a positive impact to our sustainable lifestyle.
Okay, next move to the objective. So the first objective here is to calculate resultant force acting on a bicycle during motion. The second one is to determine the acceleration of a bicycle using Newton's second law. And the third one is to compute the velocity of a bicycle based on distance and time. And the fourth one, to calculate the moment, which is turning effect in bicycle steering or component.
Okay, now I would like to discuss how mechanic principles are applied in cycling. The bicycle moves forward when the cyclist apply force to the pedal. However, friction and air resistance oppose the motion of the bicycle. The interaction between these forces determines how bicycle move. If the applied force is greater than the opposing forces, the bicycle accelerates. If the forces are balanced, the bicycle moves at a constant speed. In addition, the cyclist apply force to the handlebar to steer the bicycle. This creates a turning effect, which help control the direction and maintain balance.
So, this is the statement for our case.
Now, let us look at the real-life situation of our case study. Imagine a cyclist with a total mass of 65 kg riding a bicycle along a straight road. As the cyclist starts pedaling, a forward force of 220 Newton is applied. At the same time, environmental factors like friction and air resistance create a total opposing force of 70 Newton. The bicycle moves a total distance of 150 meters in 25 seconds. Additionally, to maintain balance and steer the bicycle, the cyclist applies a force of 12 Newton on the handlebar at a perpendicular distance of 0.4 meters from the pivot point. This data will now be used by our team to analyze the net force, acceleration, velocity, and moment of force of this motion.
Okay. Next, to begin with the calculation, the first one we have right here to calculate resultant force on bicycle. So resultant FR is equals to force forward minus force resistance. So the information here we have force forward is equals to 220 and friction and air resistance is equals to 70. So 220 minus 70 and we get 150 Newton for resultant force.
Next, for the acceleration of the bicycle, we are using Newton's second law of motion, which is force equal to mass multiplied acceleration. By using the net force of 150 newtons that Hannah calculated earlier and dividing it by our total mass of 65 kilograms, we get an acceleration of approximately 2.31 meters per second squared. This means the bicycle is speeding up at the rate along the straight road.
Next, I will determine the bicycle final velocity using the first equation of motion, which is V equal to U plus AT. Since the bicycle starts from the rest, the initial velocity U is 0 meter per second. The acceleration is 2.31 meters per second square, and the time taken is 25 seconds. By substituting this value into the formula, we get V equal to 0 plus 2.31 times 25, which give a final velocity of 57.75 meter per second. This means after 25 seconds, the bicycle reached a velocity of 57.75 meters per second.
So for our calculation moment on the handlebar is moment equal to force multiplied by perpendicular distance. For our force is 12 Newton and our perpendicular distance is 0.4 meter. So the answer after we put in the formula is equal to 4.8. So for our conclusion, to conclude, the cyclist journey is a balance of both linear motion and steering control. We found that a net resultant force of 150 Newton acts on the 65 kg system, creating a steady forward acceleration of 2.331 ms. This acceleration allowed the cyclist to reach an average velocity of 6 meter per second over the 150 meter trip in just 25 seconds. Finally, to maintain stability and control, the rider applies a force of 12 Newton at a distance of 0.4 meter from the pivot, generating a turning moment of 4.8 Nm on the handlebars.
And lastly, reference. We get reference from the YouTube and textbook. That's all from us. Thank you for watching.